Welcome to Programming in Modern C++. We are in week 2 and now we are going to discuss module 7. In the last module, where we started discussing extensions of C into C++ without the object oriented features, but other features which makes it a kind of a better C. And we discussed about how to replace macros without or with parameter by either const qualifier or by using inline functions. So, we have discussed const and volatile, the both types of CV qualifiers in this context, and discussed about how inline functions can really help. Now, today we will discuss about references, which is a very key idea in C++, which are similar to pointer, but are different from pointers. This is the module outline, as you can see on the left hand side all the time. So, what is a reference variable? A reference variable is like an alias or a synonym. Kind of most of us have some name and we have some pet name, right. Say my name is Parthopratim Das, my pet name most of my colleagues and students call me as PPD. So, PPD is an alias of my name, right. So, this is another identity. So, the alias, if I define a variable say I and initialize it with 15, let us say, I can define an alias of I by doing this, where the key point syntax to be noted is before the alias variable or reference j, I need to put an ampersand. And then after the initializer symbol, I put the variable that it is alias 4. So, if I look into that this scenario now in terms of what happens in the representation on the memory, I is the variable, it has been initialized with the value 15. Let us arbitrarily assume that its address is 200. J is an alias or reference to I, which means J is just another name for the same location. So, J is just another name, therefore, if you look at the address, then the address of I if you compute and the address of j if you compute, it will be the same value 200, right. So, this is the basic idea of an alias. Now, let us look at the behavior of an alias in the program. So, we have defined A, initialized it with 10 and a alias of A, which is B, defined as with this ampersand. So, B is a reference of A. So, A and B are necessarily the same variable, but two names of them, that is all. That is all the reference talks about. So, they necessarily have the same memory location. So, if I print the memory location of A and B, as you will see here, the values are identical and therefore, the value they print are also identical. If I increment A, say I pre-increment A, then A changes and therefore, B also changes by that, because B is just another name. So, when I print A and B after incrementing, both prints as 11. Instead, if I change B, A also changes, because it is just B is just another name of A. So, for with another increment, when I print A and B, they both become 12. So, A and B enjoy the same location, they are the same variable, they will have the same value, and changing one will necessarily change the other and vice versa. So, that is a basic property of a reference variable. Now, there are few can reference be what are the kind of pitfalls that you can get into while defining a reference. So, on left I show some of the common wrong declarations, that is, here I have tried to define a reference, but without an initialization. So, I am saying that PPD is the nickname of, then I do not say who. So, I am trying to create an alias where the original object, the original variable is not given. So, that is not possible, it must be initialized. So, I can say like this, where I is an alias or reference for j. Here I have created an alias j, initialized it with a constant 5. This is also not allowed. Why? Because an alias, how will the alias identify itself with the original variable? Because it needs an address, it needs the address of the variable. So, if this is done, then ampersand I is the address and j necessarily uses that address, which is computed as ampersand j, to be able to track that it is a second name for I, or rather I is the second name for j, here I is the alias. Now, if I have a constant, constants do not have an address, they are just a value, right. They do not have a, they do not have, they just have an R value, they do not have an L value. So, I cannot use that to define an alias, I cannot have an alias of a constant value. What I can do, if I want to do that, what I have to do is I have to define that as a constant reference. What does that mean? That means that this is a reference which is referring to an expression which is a constant. So, what the compiler will do? Compiler will specifically allocate a location for j, for 5, that j can track, and whenever I talk about j, it will actually get the 5 from that location. Similar thing will happen if I have an expression on the initialization that I use. Again, an expression has only a value, it does not have an address. It, whatever address it is computed in is a temporary address. So, I cannot have a reference to that, but if I make it const, then the compiler will actually allocate an address where j plus k is computed, and the then value of j plus k will be stored there. So, if j and k changes, that value will not change, and I will become an alias to that value, the expression j plus k. So, these are some of the basic pitfalls. So, you can see here I have I declared as a variable initialized, j declared as a reference to I, k declared as a constant reference to 5, and L declared as a constant reference to the expression j plus k, right. So, when I print the addresses and values, I will see that if I print I, it is 2, print j, it is 2, they are alias, and they necessarily enjoy the same location. When I print k, I get the value 5, and I do have an address, just 5 will not have an address, but here the compiler has specifically given an address to keep 5, which j is referring to actually, right. Similarly, j plus k has a value 7, and as a reference to that, L has an address which is given here. Again, compiler has given a specific address instead of a temporary for keeping the value of j plus k. And please note that subsequently, even if j plus k changes, the value of L will not change, because it is treated as a constant. So, it is referring to a constant always, right. So, That is the basic, these are some of the basic rules to remember. Now, let us move on to what is known as call by reference. Right? So, you all are familiar with call by value, that is what is commonly used in C. What happens is when I call a function passing a parameter, then the actual parameter value is copied onto the formal parameter value and then the function starts proceeding. So, actual and formal parameter enjoy different locations. So, even if I change the formal parameter, the actual parameter will never get changed. That is the basic scenario. Here in C++, C does not support this, but in C++, I can have a parameter which is of reference type. I write it with this int ampersand. It is a reference parameter. When I write int, it is a value parameter, right. So, if when I define the function, so this is my reference parameter and this is my value parameter. So, what it means is when I call the function say with a and a, the same variable, b is a reference parameter. So, b necessarily becomes a different name for a. B does not, the value is not copied, the value is not copied, but just you are saying that in function under param test, in this function whatever you call b is the actual parameter a, it is just a different name for it. So, if you change b, a will get changed, whereas this is a copy, because this is a call by value parameter. So, C will take the call time value of a and that will be copied into C in a different location. So, in the main, when I print these addresses subsequently, say I print the address of a and here the address of b, c, you will find that a and b, a in the main, the actual parameter, and b in the function, the formal parameter, have the same address, because it is a reference parameter. So, it is talking about the same variable only, whereas C, which is called by value, therefore, it is a copy, it is a different variable in the function as a formal parameter, will have a location which is different from a and b. Right? So, here we have learnt that how to pass parameters by reference where they are not copied, but just they become a second name to the actual parameter, and accordingly these addresses will be assigned, right, as you have seen this already. Now, let us come to one of the earliest programs you probably have written, or earliest functions you probably have written, that is swap. That is, I have two values, I want to interchange them, right. Now, let us say what we need to do in writing swap. Now, if we write swap directly by using call by value, these are call by value, and then this is the swap code, which is very straightforward. Using a local variable t, I can always write this code, and then I call swap. Now, the problem that happens is these are called by value. So, when I call it with a and b, a is copied to c and b is copied to d. Subsequently, c and d are swapped, but when the function comes back, a and b are different locations. So, they will not be swapped, they will remain to be the same. So, I pass this to swap, but on swap no changes happen, no swapping has happened. Right? This you have seen in C. So, how do you bypass this in C, or what is the hack in C? The hack in C is that instead of passing the parameter directly, you pass the address of that. So, you pass the address of that. So, now instead of calling swap a b, you are calling swap ampersand a, swap ampersand b. So, when I look into the formal parameter, the address of A is copied to x and address of B is copied to y. These copies are called by value, do not confuse. These copies are called by value, but what you are copying is the address. And then what you are doing in the swap, you are actually dereferencing that address and making the swap. So, the addresses have been copied, they are in different locations x and y, but they are referring to the very original actual parameters A and B, and so when by dereferencing you swap, effectively A and B gets swapped. That is the basic idea. So, when you swap like this will actually take effect, that is the correct way to write swap in C. Right? And when you do this, that is you use call by value, but pass addresses to make changes back into the actual parameter, you typically refer to it by call by address. It is not a very popular name, but this is colloquially most often we will refer to that, right. So, that is here you can get the summary of what I have just stated, and this is what happens in C. So, what is becoming is, if you look carefully, you will see that the call to swap is becoming somewhat unnatural. I am having to pass ampersand A, ampersand, even writing swap is unnatural. So, let us see, now let us compare this with C++ and using reference. So, on left again is the original C function which has call by value, the swap, and it cannot swap. Now, I write it in C++, instead of having call by value parameters, now I have reference parameters. So, instead of int, I write int ampersand, and then I call swap. Now, what will happen? X and y in this function, are reference parameters. So, what it means that x necessarily becomes a different name for A, y necessarily becomes a different name for B. So, whatever you call A B in the caller main is called x and y in the swap. So, when you swap x and y, actually you are also swapping A and B. So, this is actually A, this is actually A, this is B, this is B, but in the function they have different names, and that is possible because of the reference parameter. So, whatever changes you make, that correctly computes the swap and performs it. So, it makes it lot more natural, because your call is now not like ampersand A, ampersand B, you can just call them passing the parameters as they are. Only thing you need to do is to make sure that the parameters are by reference. So, kind of you can see that call by value only allows you to input a value, give it as a copy, whereas call by reference gives you the ability to input as well as output the value. Input, because the initial value will always be, the value that you called with will always be available in the function. So, it acts as an input like the call by value, but also changes that you make in that variable will be reflected back in the caller. So, it is also an output variable. Now, so when you use a call by reference, what will happen that a function may inadvertently change that variable, right. Suppose you want to use something only as an input, but you have used it as a reference parameter, and we will see the reasons of why we want to do that, because a big advantage of using reference is that I do not need to make the copy. If my parameter is big, if that is a huge object, then copying it is a huge overhead, and I do not need that. I just need that value to compute in the function. So, I would like to pass it as a reference where no copy will be required, but the side effect of that, or the possible danger of that, is if the function happens to change that parameter, then the actual parameter will also get changed, right. So, to stop that you can again make use of const. So, what you say that not only I am passing x as a reference, but I am passing it as a constant reference, which means that it is not allowed in the function to change x. The same concept of const reference we have just seen couple of slides ago. So, x is a reference, but is a constant reference, that whatever it is referring to, that referent, that value that it is referring to, that variable that it is referring to cannot be changed. Therefore, if I have this and I write x plus plus x and then return x, this will not compile. It will say that x is a constant and you are not allowed to change x. So, you cannot do plus plus x, because plus plus x will necessarily change x, which effectively will change a, would have changed a if compiler would have allowed, or if I did not give this const. Whereas, I can write it like this, it is a constant reference. Instead of doing plus plus x, I compute x plus 1, which is necessarily what I was doing on the left column. Then it will be allowed, because you are not changing x in the function ref const. Right. So, in the left the code will not compile, in the right it will work properly and give called with 10, it will print 11, there is no violation. Right. So, this is the constness of the reference parameter that you will have to keep in mind. Now, the question is, if I can pass values by reference, can I return values by reference as well? Yes, I can. In C, as I do call by value, similarly I have return by value. The value that is returned is actually returned through copy. Whatever you write in the return statement will be returned as a copy of that. So, here I have just made a function which is pathological, it is not doing any computation, but it just takes a variable and returns that same variable. Right. So, return x, and this is the C return by value mechanism. So, it will simply return a copy of x. Right. So, when I do this, I will get a copy of x. So, a and x will necessarily have the same location, whereas b, which I am making a reference to the return value, has a different location. Now, I can return this reference by return this value by reference. So, all that I need to do is again put an ampersand after the int, which means that the x that you have in the function will be returned by itself, not a copy of it. Right. So, when I set int ampersand b, it basically becomes the reference to x, and you can see that I pass the parameter also as x. So, x is an alias of a and b is an alias of x. So, necessarily a, x, b, all of them are the same location, whereas here b, when I reference, it is a different location, because it is not x, but a copy of x, a temporary that is created. Now, the question is, here you will note that I have written const. Why did I write a const? For the same reason, that if I am defining a reference and my initialization is an expression, then the value of the expression is a temporary, which will not be stored otherwise. So, to give it permanency, I need to make it constant, so that the compiler has retained that address, that location, and have kept the value of function returned by val a into that location, and b is now become a reference to that. So, in here x is a reference of a, but b is not a reference of x, but b is reference to the temporary carrying this entire expression. In here, when I return by reference, using this constant is not necessary, because this by itself is a variable. Right? So, return by reference can also get tricky. You can see that for example, you can write something like this, which is kind of some syntax. You will say, oh no, there is error. How can you write function on the left hand side? I cannot write function on the left hand side if it is returning by value, because it is a value, it does not have an address. But and on the left hand side I always need an address. But if I am returning by reference, then what I have is a variable, it is an address. So, I can always write it on the left hand side. So, if I write it like this, then in this case what will happen? A is x is a reference of x, and that x is what is here. So, this actually is x, which means A. So, the assignment actually is happening to A. So, A becomes 3. Whereas, if I have used a temporary here and say incremented that temporary, that is not very important, and I return that temporary, then this is a reference of this local variable t, which actually has no existence after the function has returned. So, it is actually dangerous, right. So, it can be very, very risky, and this assignment will be made to that temporary t which I have returned by reference. Therefore, A will not change and it will remain to be 10. So, this can get you into really big trouble. So, the thumb rule to remember is when you return by reference, never return a local variable. Right? So, if I summarize the input output parameters of a function, then these are the different possibilities. If it is a value parameter, then the purpose is to input, and you can use call by value. If it is a reference parameter, then it serves as input as well as output. It is called by reference. If it is a constant reference parameter, then it is input only, call by reference in constant. And for a return value, you can either have return by value, you can have return by reference, or you can also have constant return by reference. And remember that C has the mechanism in C that we saw, call by address, which is call by value with pointer, and similar corresponding return are also available in C++, but there is no reason to use them. You will not find any situation where you need to use them. So, always try to avoid them. So, instead of the recommended mechanisms as to how reference can help, when you are making a call, if you are passing a built-in type, always pass it by value. Right. The reason for that will become clear as we move somewhat forward. It gives you a much better efficiency, because the copy actually is very lightweight. Only remember that array parameters are always passed by reference, even in C. In C, that is the only situation where the entire array is never copied. It is just passed by reference, which means the base address only is passed. Right? Same thing happens in C++, but any parameter which is of user defined type, pass them by reference, because you can avoid unnecessary copy of big objects by passing by reference, which is not possible if you pass by value. Similarly, for return, if you are returning built-in types, do by value. If you are returning user defined types, do by reference, and reference value is not copied back, it is faster. But remember that the calling function, the caller can now change the returned object. So, you have to be careful about that and never return, as I shown, any local variable by reference. So, before we summarize, let us just compare the pointer that you knew and the reference. Both of them refers to an address in some way or other. In pointer, that address is exposed, you can print that, you can do computation with it. In reference, you cannot do that. So, those of you who know Java, please do not relate reference here with the reference in Java. Reference in Java is neither exactly a pointer nor exactly a C++ reference, right. So, please do not confuse that. Pointers can be null, reference cannot be null. You will also always have to initialize it, as we have seen. References can be pointers can be changed from time to time. I can define a pointer and let it point to different objects, but reference cannot be changed, it is by birth. So, once you have made a reference to a certain variable, you will have to, the reference will always be made to that variable only. For pointer, you need to do a null checking, because it may not have been initialized. In reference, that question does not arise. Pointer allows operations on the address, like you can take diff of pointers, you can increment and so on, but in reference you cannot do anything of that sort. Whatever you do with the reference actually means the variable, the referent that the reference is talking about. Finally, arrays of pointers are possible, arrays of references are not allowed. So, this brings us to the end of this module. We have introduced a very important concept of references in C++ and studied the difference between call by value and call by reference, or return by value and return by reference. And this idea will be used very heavily all through the course. So, please try out these examples and try to understand it well. Thank you very much for your attention, and we will meet in the next module.